We, as a business, are a bit different to most as a head contractor. We have been on a long journey of prefabrication from unitised building, which we no longer do, to what we call now the HBS system or Hickory building system. One of the reasons that we're doing and investing so much time and money into prefabrication is, as a group, we are aiming to build buildings at 0 defects. Sounds like everyone tries to do the same thing, but the only way we can do that is actually change the way we build. Our system, the systems that we use increase speed on a project, and we're getting some unbelievable results, safety and quality. So we're investing a lot into it, and we're in an amazing place right now. Because we're a self-performing business, we own a structures business, a logistics business, a facade business. We're very advanced in modelling at 5D at the moment, and we'll go through some of those a bit later. By being self-performing, we're able to get to a decision very quickly. And be able, for the design process or an ECI process that we normally run through with projects, we get through it very quickly because the people in-house come up with the solutions very quickly. We're not relying on the outside market at all. We believe in some terms that we call innovation multipliers. Here you'll see some parts. The centre one is bathroom pods, which we have a bathroom business called Sync, which services the whole of Australia. A lot of our competitors also, of course. We do 500 bathrooms a month, going to 1,000 bathrooms a month early next year. We also have what we call HBS, which is a prefabricated structure, which you'll see a little bit more about, which resolves a lot of the narrow sites that we have in tall towers. We're a specialist high-rise builder. Our system's pretty cool. It's a concrete floor poured upside down. It's the quality of the floor is plus or minus 2 millimetres because it's flat as our panel bed. We can locate the facade on the floor in the factory, which means that we don't have screens on buildings or handrails because the facade's already there. So we've taken away, it's probably the safest form of construction of high-rise. Put the floor on, you put your verticals on, whether they're precast, however the building's designed. Then you drop the bathrooms in. Then we also doing MEP, prefabrication of MEP. So we broke a building up into parts, and you'll use the building will dictate what parts we use. When we talk about systems, and they talk about volumetric modular and all that. If a system, and people sit in the room and go, some of the challenges we have with prefabrication is we need to be really early in the design process. I actually think that's flawed. So we used to be like that, and we've evolved into something else. As if systems are going to dictate design, they're not systems, they're products. Our system does flat PT slabs, beam and deck, flat conventional slabs. It does all types of concrete slabs. It is a system. So therefore, the architects can design buildings for the best value needed for their environment they're in, the yield, the developer, the customers, and all of that. And our job is to just to be able to build it faster and better, which is what HBS does, which is, I'll show you a bit more later on, which will make a bit more sense. So, and the building dictates what we use. One of the buildings there on the left in South Yarra, that was fully conventional. This one with 568 Collins Street was about 70 levels. We used bathroom pods. The one here, which is 50 Trobe Street, which is 700 or 800 rooms, student accommodation. It's 2 buildings. One's 42 levels. There's a little one at the back in Bell Place, is 7 levels. That's in construction right now. we've got a 19-month construction time for that project, which is very quick for a 42-level building. Conventionally, it'll be about 26 months, so we've shaved a lot of time off the program. The other building on the right here is not using bathroom pods, but is using a fully integrated HBS structural system. That building there is 460 Collins Street, which is called Collins House. Amazing building, 11 metres wide, 40 metres deep, 15-level car stacker, then counterlevers over the neighbour's building by 4.5 metres as a glass box, and goes up to 57 levels. That's been all done with the HBS system from level 15 upwards. So it's got PT in the system. So the building's dictating what we use, not the systems. We've developed kept developing what we call a dumb smart model, because it's out of Revit, which we give to our consultants during the process. This smart model has all the parameters of our system. So when we look at a site, we go, we're going to make these panels, we're going to put the parameters of 12 metres by 3 metres of our panel size. We give that to the design group and say, here's your parametric model. And within that parametric model, there's all the temporary work systems inbuilt in it, the facade, set downs, and everything. The logistics dictate what size we put it, and the design team doesn't change. They've just got better tools to use, and they design the building using the system. We do a 50-storey model, a building of a 50. That 50 Trobe Street building took us probably about 2 or 3 days to model the whole building. So, because of the self-performance of what we do, we're able to collaborate. Our collaboration with the design team is just so much more efficient. A lot of the problems that you'd see that when we're designing buildings is decision making. Later on, I'll show you a bit of a gated process that we run by, and by having a self-performing arms to our business, we're able to get through the decision making a lot quicker, and mitigates a lot of risk. Prefabricated solution. So this building here that you see, there's 323 Trobe Street, which we finish as also 42 levels, 40 odd stories seems to be the flavour of the month lately. That was the same thing, one basement, 42 levels, 18-month construction time. We finished that last year. That had a lot more steel in it, our system then. Now there's no steel in our system now. It comes with an integrated core, shear walls, and of course the facade. The longest parts of when we're building a building, the time we lose the most is when we're doing the conventional process. Because the system, because we pour things upside down, we've got set downs, and I'm a big fan of having set downs for bathrooms. I don't think it should be done any other way. But because we design, it's such an efficient way of designing a structure where we can move beams, and when we're doing beam and deck, we can move our secondary beams. We're able to really get a lot more efficiency in the height, the floor-to-floor levels. Which, especially in London, we're able to get a lot more levels on buildings. But even here in Melbourne, we're able to squeeze our floors even tighter than we would conventionally. So, aim is 0 defects. People say this all the time. Lots of contractors will sit up here and say, this is what our aim is, but and they'll have processes and systems and try to get these things right, and checklists and all the rest of it. But there's all very different people on very different floors and spread out everywhere, and it's very, very hard to do that. Our bathrooms leave our factory at 0 defects. 2 things go wrong in construction and the way we build buildings is, one is design and the other one is human error. BIM modelling is not the answer. That'll give you 85% of design. Prototyping is a validation of design. So you walk in it, yes, this is what I want. Human error is the tough one to fix. The way we we eliminate human error is by process. Our ceilings on our bathrooms are made by an aluminium, composite aluminium ceiling. It's white, looks like plaster, exactly like that. But it's cut with a CNC machine. So therefore, the lights are always in the right spot because a human didn't do it. The computer did it. Our walls are made by computers, by roll foam machines. Our bases are made by GRC, which comes out of a mould. There's all these processes that are put into place that eliminate human error. Our people do the same thing over and over and over again. And we also have a multi-skilled workforce that they can go from one station to another. The bathrooms, it seems crazy a lot more people aren't using bathrooms. When you come and see a bathroom pod business, you just go, it's a bit of a no-brainer. It makes nothing but sense. We cannot build bathrooms on site to the quality that we build them in the factory. Impossible. It's impeccable. Our BIM modelling, our bathrooms, when we're designing, if we don't have the sample of the tile, we can't start designing the bathroom because if it's 1 mil difference, our whole model falls to pieces. We don't have slithers. We're within 1 millimetre. Our floors, our structural system, the same thing. We've got processes to eliminate human error. It's poured upside down. Our quality of concrete is plus or minus 2 mil. When it gets installed, it goes to 0 datum at every floor in X, Y, and Z grids. Our floors as a finished floor on site are plus or minus 3 millimetres. They're reset, right? We have floors in buildings now at 50 Trobe Street which are so flat that we could not art the floor at that quality. It's incredible. What does it mean? Well, there you go. Trobe Street. Conventionally, 42 levels, 27-month contract. We signed a contract at 19 months. 323 Latrobe Street, which is called Latrobe Tower. We signed a contract at 18, similar sort of time. Collins House, the market needed, it was engineering-wise, it was probably one of the most difficult buildings in Melbourne. I think it's the 4th most slender tower in the world. The market and our competitors and us, of course, if we were building it conventionally, needed 40 months to build that building. We signed a contract at 29 months. It made the project viable to be built. And Pepper's, the little one we did in Perth, which is like doing a project in another country. It was on a little hotel. It was 11 months to build. They're pretty significant. So our quality is significantly higher with prefabrication. And our safety, it's the safest system in the world by far for high-rise because we don't have live edges. And our quality is what Hickory is striving to achieve at 0 defects. Well, time taken to build, significantly less. Safety was spoken about. Truck deliveries. This is actually really interesting. Truck, noise, and waste. These are really significant. Waste, we use 90% less waste. We have 90% less waste. Noise on site. We were doing 323 Latrobe Street. Very funny story. Said to council, this was our system, had steel in it, and they were a bit bigger. Council, we need to work at night because the permits were issues with trams and bike lanes and everything because it was a very narrow site. Council's gone, no, you're not working at night. State government kind of like us because we're employing lots of ex-auto people. They came and helped. We said, we make less noise than the ambient noise of the city. Council said, no, you don't. You're talking crap. You're just another builder talking rubbish. We said, seriously, we make less noise. Here's the data. Here's all the tests that we've done. We'll give you a permit. They gave us a permit. We built 42 stories, and it went really well. Next project came along and says, cool, we've changed our system now. We haven't got steel. We can make the modules any size, so we don't need to work at night. Council's gone, we need you to work at night. We was the only project that we've had that did not have any complaints for the whole 40 levels of the building. We were there for 2.5 hours to put 400 square metres of floor in with a facade. We made no noise. We took 70% of the transportation we took away from the city during work days. It's really big. Like when we've got trams in the city, we've got all these things. We did not disrupt the city. Well, it makes a bit of sense. We only have about 10 to 12 people that work on site when we're installing these. So we don't have a lot of people on site. Our concrete that gets poured on site is about 5% of what would normally be poured in conventional construction. So we've got less trucks on the road in the city areas. They're kind of big things, huh? Safety is always the number one, but you know, when you're talking about a disruption of a city, it makes it pretty significant. So this building was designed by Rothy Lohman, awesome architect. Project manager Sinclair Brooks, developer, which is super cool, which is Long River. 44 levels. It was an 18-month contract, not 19. And 206 apartments. Site was about 400 square metres. It had no access at the rear. It had no access on the sides. And it was as tough as you get. Right near, very close to an intersection, bike lanes, trams, really difficult. Conventionally, it would be a 27-month contract, and we built it in a very short period of time. We did some pretty amazing stuff there. With a lot of the shear walls, the modules came with the Rio on it, the outside face of the precast. You sort of see over there. Has the outside face of Rio. There's a 400 mil thick shear wall. Module came with Rio, and we used shotcrete for our shear wall to bind the two walls together. Lots of testing went into that, and it worked really well. And I would say it's probably the tallest shotcreted building in the world, in my opinion. I've never seen anyone go this high. We don't do that anymore, actually. We've developed even further than that. And we will still keep developing. The system today is going extremely well, and there's changes coming again. We constantly evolve and continuously improve. You can see here, this one had, you can see the steel, it had a 85 mil thick floor slab with a steel chassis. See the module here, this had two sides of facade with all the fins on it, and you can see it in construction here, they're going up the top, where the shear wall drops off there. You can get onto this, or am I supposed to play this? I don't know if we can give it a play. How would I play that? That doesn't matter. You can get online and see this. What is it now? Well, now all the steel's gone. There was steel around the perimeter, which has just been designed out. We call it a cold shell. It comes set down, fire collars, all the penetrations. It comes with a facade. We stitch it together with lots of different jointing systems, some as a straight joint with couplers. Another one that we do is with a tongue joint where with a straight joint with couplers has a formwork system. In the formwork system, we have our propping system, which are 200 kilonewton props. They're very high performing props. What happens, you put the floor on, floor comes with the props, or you recycle them up the building. It's got a drop head, you put your bearer through, use some prefabricated panel system that we use that goes on there. The next module comes on top, and which forms the edges of a beam, if it's a beam and deck, and sometimes we put an angle down there that we cast in to form our deck, which ends up being there. Or we have a tongue joint of a conventional slab and just fill in between those two concrete slabs. There's a lot of different systems, different details for different slabs. Some have got PT in it. Collins House has got lots of PT. Because we pour it upside down, the pans that we put for our PT no longer are sticking up. I don't know if anyone really knows lots about technical in construction, in structures, but PT pans is a pet hate of contractors because we have to fill them and then grind them, and they're really, really expensive to do. This has taken me 25 years to get over this one. Now, because I pour it upside down, the only way it can go is upwards, so our floors are perfectly flat, which is almost brought a tear to my eye, to be totally honest. You can see this module here has the Rio on it on one side. We do that sometimes. We've got lots of different systems that we can adopt for each site. And here, the facade panel will clip onto the module. We don't have props for the precast in this situation. The module picks it up. You put the precast through for your blade walls or columns, and there's just grout tubes that go through, which is a very simple details. I'm missing a slide. I'm actually missing a slide, so I'm going to go back a bit. We've got a gated process in design. Okay, that's cool. So we're a gated process in design. So when we design a building, ECI, we tender a building, we're a bit faster. We get to an ECI, we tell the architect, go see our pod bathroom business and start working with them in finishes. And here's your concept drawing for your facade. To get to the ECI, we get the concept for the facade. So yes, that's the facade we want. We mainly use curtain wall. Thumbs up, here's your engineering for it. And whatever facade they've designed, it's not our design, it's theirs. We then give us an XYZ grid for the facade. We're starting the shop drawing process now. Structural engineer, do not touch the floors. Don't go near the floors. They're none of your business at the moment. Stay in the ground and do your basement works. Give us the basement groundworks. Architect work with the bathrooms and XYZ grid. Facade shop drawing start. Bathroom starts. And there's some gates to all of that. Service engineer, give us a full BIM coordinated model on your services. After the services are done, the structural engineer, we go, come here. Here's your parametric model. This is where I want my beams. And this is what it looks like now. So this structural engineering, instead of, because the service engineers normally come in and say, I need this much space, and the engineer designs really big beams, but they actually only needed this much space. And it's just a waste of time because there's not many, they always try to get what they can before design's finished. So services first, then the structural engineering, and then the process goes from there. By the time the structural engineering is finished, we have our facades are in manufacturing. Very, very quick process because I can't build a building without the facade being in the country. We're doing lots of collaboration, joint ventures around the world. We're with partnerships with Mace in London, Singapore, starting New York and Japan.